practice as well and play around in apps and see the more you can do. Your instructor, so you have a lot of work to do, a lot of reading to do, a lot of practice to do. What we do a lot of guide support. And so after this training, we're going to give you more support. And we usually come up with retooling section and ensure that you're still within the loop of the learning process. So be rest assured that you're in the right place and you don't have any cause to not to deliver. So if you have challenges as you go on with your academy, you let us know, and we'll be there to give you all the support. Yes, okay, so I'm going to start right away. Trying to round up to the three where we stopped last time, and then see that I think somewhere here. Okay, I think I stopped here. So if you can recall, I think we stopped with the risk and the CISC. Am I correct? Am I correct?
Yes, sir.
Oh, thank you. If you're coming in, please, you kindly mute your audio, and then when I ask there's any question, then you can go ahead and ask. Okay, quickly, I'll summarize this. We talked about the CPU architecture. I did told you guys that the CPU constituted of logic circuits of transistors. These transistors take in input signals of ones and zeros, and this is how they've been operating. Uh, and then it's quite complex because the speed of the computer is actually seen from the number of transistors project. And as computer demand grows, the tax for computing also grows. We begin to see the complexity in the transistor. The transistor, we've all agreed, is the brain of the computer. The computer does nothing without the processor. And so it's quite important to actually have a very good understanding of the CPU. I'm happy we're now we've all agreed that the CPU is not the computer case like other persons presumed. Neither is the system unit. So the CPU, you can see the picture there. It's quite small. Sometimes in some places in Nigeria that I've come across, they'll say, "Oh, CPU." They keep calling the small box CPU. So it's been a wrong one, and we'll be trying to correct that narrative. And so we say there are two distinct types of instruction set that CPU may use. For your information, CPU itself is a hardware and contains instruction set, and this instruction set determines how the computer system fetch information, decodes information, and execute information. And so if it's going to do that, we said it has reduced instruction set computer and the complex instruction set computer. And then so one of you actually also gave an insight of the 8086, which is the complex instruction set computer. This actually has been like the legacy kind of computer, but processor, but it's still in vogue. But then I need to just give us a very simple way of differentiating the two. The first one is reduced, actually try to reduce the complexity of the instructions. And so you have very few instructions to carry out the heavy tasks, and then it works with high speed. But the complex instruction set computer actually has complex instruction sets. Of course, considering the fact that it's a legacy and it's just like an upgrade, coming up to be like the reduced instruction set time computer. This is the 8086. And so the question now is that where do we apply both? Where do I use, where is the reduced instruction set computer used, and where is the complex set computer also being used? For the reduced, which is RISC, is actually used in telecommunications, in video conferencing, high tax and computing processes where you need to do a lot and then you demand high processing power, and that is where you deploy the RISC. And so you can see that it's faster, It's for the 21st century multitasking in computing. But for the six is actually being deployed in the case of look at your security appliances. You quite agree with me that some of them contain they actually have processors in them, and so for things that actually require high processing abilities, they actually use the CISC, which is the 8086. So if I have for instance, I have a CCTV camera. I don't expect the CCTV camera to run the same process like a server that is meant to do a lot of computing processes, probably in telecommunications and all of that. So you can see the difference here. So it's been applied based on the use itself. And then, of course, it will be cheaper. You know, when you look at the cost of every computing devices, once you look at the size of the processor, it also determines the cost of that particular device. It's actually very expensive to build one, even though it's been cloned. So while the CPU is executing one step of the program, the remaining instructions and the data are stored nearby in a special high-speed memory called the cache. Remember, we said we have cache memories, and these cache memories are inside the processor. You can still remember that is hard, and that's one of um, the things you can see for i3, i5, i7. They have cache, so it makes it faster. Okay, enhancing CPU operations. Intel processor uses hyper-threading enhanced to enhance the performance of some of their CPUs. Hyper-threading is only noticed or seen in Intel processing. And what is hyper-threading? Hyper-threading is when you have those cores. Remember, we defined core. We said core are like um, the connection, the circuit, the logic circuit connection inside the CPU. And in before now, we usually have the processors which, excuse me, 1 minute, please. Just 1 minute, everybody. 1 minute. Okay, but just 1 minute. Let me just. Okay, sorry. I remember we were talking about hyper trading. Um, Hyper trading, because these are some of the little questions your student might be asking you, and you need to study the material to be sure that you actually get each of these terminologies correctly. The good thing about the course like this is that it will to broaden your knowledge of understanding, and then help you to be able to meet up the current knowledge requirement for teaching ICT courses, especially when it has to do with the basis. So the hypertraining has to do with the calls, how these calls are being expanded virtually. And it's only in Intel processor you can actually say this. It's not common with the AMD processor. And so you have a single core that seems to behave as it were double core in terms of execution. So when you have the processor being subjected into probably activities. It has to now trying to create that uh, image as if it were like double cores, and then with that be able to carry out more tasks. The aim of all this is just to still help you process your data and enable your system to work faster. So that is what hyperthreading is, and it's actually for linking up all the cores. For your information, the processor we used to have now are made up of single core, but today um, we have cores. You know, I gave an assignment. I told you guys long ago. I think was it my first lecture, or second, that I said you needed to help me find out the speed for each of the core families. In other words, the core i3, i5, and i7. I don't know if any of you have done that assignment, but I think you need to look at that. Look at the frequency range. Remember, the unit of CPU is in hertz, so you need to find out what is the range for core i3, what is the range for core i5 and i7. And then when you now come, I'm talking about the frequency range. And when it now comes to the core, the question is that I'm adding this also as an assignment too, in the same for the same category of assignment, that you also need to help me find out how many cores do you have in core i3. Does it mean if it's core i3, it means it has 3 cores? Does it mean it's core i5, it has 5 cores? But I wouldn't want you to do such interpretations to your student and say, when you say core i7, it means it has 7 cores. You might be wrong. It does not have that direct meaning. So you need to check out the cores and then do that submission. AMD processor use hypertransport to enhance CPU performance. Well, hypertransport is a high-speed connection between the CPU and the NOT bridge. If you remember, we talked about the NOT bridge and the South bridge. And so where you have the CPU, the RAM, that's where the area for the NOT bridge, and where you have your input-output is where you have your South bridge. So the power of a CPU is measured by the speed of hertz, which we say you can have it up to gigahertz as the case may be. And so multi-core processors have 2 or more processors on the same integrated circuit. Remember, the aim for multi-core processor is because you're trying to see a situation whereby if this particular processor is working, the other is in idle state, and so you end up having speed at optimal level. Before now, when we usually have one single core processor, the problem we have is that it's called that after so much tax on the system, the efficiency drops, and then you see the system becomes very sluggish. But the present day processors have the ability to still give you about 95% uptime, efficiency at all times because of the flexibility in switching from one processor, that's for the multi-processor types, and even for the Core i3 and i5. So those cores, remember, like I said, they are actually logic circuits built inside them, and each of them is dependent, but they are linked by the hyperthreading in the case of the Intel. Okay, and so we have a single core, we have the dual core, we have the triple core, quad core, and that's just in that order, trying to increase the number of cores per processors. And that's how you see that. All this is just to increase the speed of the processor. Another feature found in the CPU is an integrated graphics processing unit, which is the GPU. The GPU is a chip that performs rapid mathematical calculations required to render graphics. So you can see this is another kind of processor. For your graphics, you also need to look at what kind of CPU is in the graphics card also, and for graphic processes and all of that. So these are some of the requirements you need to let your student know. Sometimes I ask my students when I'm teaching the course like this, I tell them what are the different components, or what are the components that help in speed up of your computer systems, or if you're to go out there to make computer procurement, what are the basic things you'll be looking out for, you know, in terms of your specifications. You need to be able to have some guide. I'll be looking out for a graphic processor unit of probably this particular range. I'll be looking out for this kind of processor with such core. I'll be looking out for this RAM size. I'll be looking out for this kind of storage. You need to let them know all this because it is good for today's business. If you don't have all this knowledge, you end up buying computers and feel bad at the end of the day because you might not be able to achieve your objective. Some people want to buy a computer, just go out there in the market and say, just give me a computer, give me the one that can help me do my job. I want to use MS Word and it. So we are beginning to leave that particular stage. We are no longer in that stage. So as instructors, you also guide your company, you guide your organizations, you guide your ministries. Anytime they are doing procurement, you help them debug this requirement, this specifications, by actually looking at the different components that were based on specification. And then you can even give them a guide and say, oh, if we need to carry out these tasks, this is the kind of computers we should be looking out for. And I think that would go a long way to help your organization to grow. CPU cooling mechanism, still with the component of the CPU. Uh, the CPU has a case fan for blowing out heat from the CPU. It has a heat sink that enables it to be able to take off heat with the help of the thermal conductor. So you have a thermal conductor lying at the back of the CPU with the heat sink on top of it to absorb heat from it. And then we have the graphics card cooling system, water cooling system, and all of that. These are all cooling mechanisms for the CPU. Now, the RAID concept, computers can implement redundant array of independent disks, RAID technology. The RAID technology provides a way to store data across multiple storage devices for availability, reliability, capacity, redundancy, and performance improvement. When we talk about RAID, I oftentimes enjoy this RAID concept or RAID technology when you look at the server computer. This course also will give you a guide to be able to handle servers as well. If you look at the computer server, there's not much difference between the computer server and your normal PC. It's just that you end up having robust components in the case of the server, unlike the CPU. So for RAID actually carries various uh, um, tasks like stripping. Stripping enables data to be distributed across multiple drives with a significant performance increase. However, the failure of a single drive means that all data is lost. You can see you have one data, you have one drive, and you lost. There's some kind of power surge on the drive, and you lost that. You lost your data. It's gone. Mirroring stores duplicate data on one or more other drives and provide redundancy so that the failure of a drive does not cause the loss of data. Parity provides basic error checking and fault tolerance by storing checksums separately from data, and it enables the reconstruction of lost data without sacrificing speed and capacity. And then double parity provides fault tolerance for up to two failed drives. Now, these are some of, do I say, the advantages you derive when you're implementing a RAID system. And so, for instance, if I procure a server that have 8 drives, 6 drives, I am actually meant to implement a RAID kind of system such that at every point in time activities is going on in that organization, like in the banking sector, where they do a lot of financial computations here and there. You have the primary drive, and you try to make sure you have implemented reading such that the mirroring process is working to store duplicate data on one or more other drives and provide redundancy in case there's a failure with the primary drive. And then all these RAID systems we're seeing here, they come in categories. We have the RAID 1, the RAID 2, we have 0 in that category. And you have to implement based on uh, based on the ability of the server itself. Some of them will come, they'll tell you we can be able to implement RAID 5, RAID 4, RAID 3, RAID 0, 1, 5, and 6, 10. So you can see we have it in this category. There are several levels of RAID available. This level use mirroring stripping. So they must have these conditions. They must have stripping, mirroring, parity, double parity. Not all of them have all in working uh, as a single unit. Rather, you have like in this case higher levels of RAID such as RAID 5 or 6 use stripping and parity in combination to provide speed and to create large volumes. So in this case, you're seeing it that it does not have the mirroring. So now all you need to do here is look at the RAID level and look at what the futures, the advantages, and the disadvantages. So that when you're making um, procurement for server systems, you already know what you're looking for. You need to say, oh, we need RAID 5, we need RAID 6, we need RAID 1, and this is the reason why we need it because of the tax. Okay, but of course, for your information, the more you go higher, the more money you need to put in. So all these things they come with extra cash. But it is important you know all this so that it will help you to make a decision. Remember, you need these to help the executive to make important decisions. And of course, when all these are there, remember the role of ICT in every organization is to help the organization to reduce losses and cost, thereby increasing profit. So, and all you need to do is to be able to let them know the reason why you're going for this. So, ports, connectors, and cables. We have legacy ports. We have the serial ports, as you can see from the picture, are used for connecting various peripherals, such as your printers, your scanner, modem, console connections, network devices. You have parallel, used for connecting to various peripheral devices, commonly printers. You have game used for connecting the joystick input. You have the PS2. So these are the pictures for each of these. And the good thing is that you can be able to marry each of them. Then you have a VGA for, you can see your VGA for graphics. You can see your DVI, which provides support for transmitting uncompressed digital video. You can see your HDMI that carries the same video information as DVI, but it's also capable of providing digital audio and control signals. And that's an improved side of what you used to have before. And DisplayPort designed to replace both DVI and VGA ports. So you can see the ports there. And so this is just to show us a different connectors and ports and cables. I have another assignment. Please be writing down my assignment too. When I teach my students, I give them a lot of assignment, sometimes outside the curriculum, just for them to do extra search and be able to balance their knowledge. I'm just going to I'm giving you, but what I discovered in this class is that each time I give an assignment, just few of you return the assignment. Some of you just even wish I don't even remember some of them. Hmm? Please, you try and do assignment. It's good. You've decided to take a course like this, and so there's need for you to sit up and follow your instructor. It's just 6 weeks, and after which you're done, you do your exams, and then you move on. And then you be sure that you've gotten the right knowledge for this level. Okay. USB cables and connectors. Still under port connectors and cables. Over the years, USB has evolved. We have the 1.0, 2.0, 3.0. You can see the picture of the USB there. You lots of you, of course, use your USB for your keyboard and for your mouse and all of that. So we have the type A, the typical rectangular connector found on almost all desktops and laptop computers, TV, um, console, and media players. You have the mini USB. You can also see the picture there. You have the micro USB. So we have different types of USB, as you can see. Okay. And SATA cables. These are the different types of SATA cables we have for your hard drive connector. Um, eSATA and adapter and all of that. So you can see the picture side by side. So if you open your computer systems, you'll be able to relate with it. And here is twisted pair cables and connectors. If you actually work in an IT environment, you will have actually come across this. These are network cables for connecting um, to the internet or to your intranet network. Um, we have the twisted pair and we have the untwisted. We have the shield twisted and the unshield. We have shield twisted and the unshield twisted pair cable. So if you have a UTP or the STP, as you can see from the diagram here, RJ45, each end of the UTP cable must be terminated with RJ45 connector. So what if you look at by side of your computer, laptop or desktop, you see port for RJ45 connector, which we use a lot. And the RJ11 is used for telephony kind of network. It actually contains 4 pair. So the difference between the RJ45 and the 11 is in terms of the pair of cable. For the RJ45, you have 4 pair. For the RJ11, you have 2 pair, and is used for telephony. So and then we have coaxial cable. You can agree with me. Your DSTV cable uses coaxial cable. And then we have the BNC connector, which for digital audio or video signals, and for your CCTV and all of that. So these are different connectors with the pictures for you to actually relate with them. And then monitors. Monitor terms, we have the pixel, a tiny dot. So these are terms for monitors and the rest of them. You can actually use in this picture use multi monitors, probably from a single CPU. So adding monitor can increase your visual desktop area and improve productivity. So the added monitors enable you to expand the size of the monitor and duplicate the desktop so you can view additional windows as you wish to. All this is just to show you that you can actually connect them from your system. So computer configuration. So the motherboard upgrade, you can upgrade the motherboard based on certain component. If you upgrade or replace a motherboard, consider that you might have to replace other components, including the CPU, the heatsink, the fan assembly RAM. So these are requirements for upgrade. And why do you need to upgrade? You need to upgrade for several reasons. Probably you want high speed. So to upgrade a motherboard from a computer case, follow these steps. These are procedures for upgrading. Record how the power supply case, fans case, LED, and case buttons attach to the old motherboard. So in other words, we're saying take a deep study of your uh, current system before you disconnect the cables and record how the old computer is being secured or how it's been assembled before you begin to remove and then begin to upgrade. For your information, when you're teaching your student, let them have a very good study. Take pictures of what they already have that is working. Tell them to look at the different way the cables are connected before they start disassembling. You don't just start disassembling and say, okay, when I finish, I start connecting. They can actually do that and even video you when you are disconnecting and all of that, step by step. Step one, do this. Step two, do that. So as you're doing it, they are videoing you. So when they are done and they want to do theirs, they can actually watch it and do it, you know, one after the other. And then one thing about all this, and it comes with practice. The more you practice, the more you get yourself familiarized with the environment. And so for the CPU, one way to increase the power of the computer is to increase the processing speed. By upgrading the CPU, the new CPU might require a different heatsink and fan. For information, when you are upgrading the CPU, you're also going to upgrade the motherboard. You can't just upgrade the CPU and leave the motherboard because the truth is that the design of a motherboard comes with the CPU, and or probably if you're going to upgrade, you must make sure the new if that motherboard also have the ability to take higher kind of CPU. But in most cases, new upgrading of CPU require a new motherboard. You must apply thermal compound between the CPU and the heatsink and fan assembly. Um, this comes with experience. If you put the CPU and the thermal conductor is actually a kind of a jelly-like substance that is being rubbed on top of the CPU before you put the heat sink. If it's not there, your CPU is still overheat. And the effect of overheating means that you have instability in your operating systems going off and your system going off and on. So you can actually do storage device upgrade, peripheral upgrades like keyboard, mouse, power supply upgrade. You can upgrade your power supply. Remember, when you're upgrading your motherboard, everything begins to upgrade. The power that must drive everything has to also increase. So in this lab, you gather information about hardware companies so you can upgrade your customers' hardware so they can play advanced video games. So when you're reading through the computer, the slide, the main um, course material, you come across a video game. So configurations for specialized computers and thick and thin client. So computers are sometimes referred to as thick client, sometimes called for fat client, thin client systems. So how does that work? Um, and then we also have the network attached storage device. So we have different types, like a thin client system where you have one server actually feeding all the monitors and all of that. And for network attached storage device are servers that are connected to a network to provide file level data storage for client. So you have network attached to what storage system, storage server, and to give everybody access. So that's more or less like on the network. And sometimes the device can offer additional functionality such as your web hosting and more. Of course, when we design our, and this is very, very appropriate because probably in the third world country where some of us are, we usually have power problem. So we have to depend on services like this, where somebody else hosts a server somewhere, a physical server, and then tell you to pay annually, and you pay for ensuring that your server is up and running, and you keep paying for space, you pay for security, and I think it's a good business. It's a very good business because all I just need to do is to find myself in a country where I know there's stable power, stable internet service, and all of that, and then all I just need to do is to put it on the cloud, and people begins to pay for such services. If you're in the third world country, we so much depend on this. We rarely could host our own server locally because of the power situation. Okay, so save the disposal of equipment for information when you do upgrade, when you do replacement of faulty parts on your computer systems, when you change toner and all of that. It's expected that you find a way to dispose these things. So the proper disposal recycling of hazardous computer components is a global issue. Some of them are not biodegradable. You end up you have to find a very good way to dispose them. Make sure to follow regulations and that govern how to dispose of specific items. There are rules when you buy this computer parts or you're using this computer system. They tell you the different ways to dispose them. So it's good we stick to those rules, and then of course go through your manual to be sure that you are following the rules. So there's data safety sheet for that, safety data sheet for that. You have to go through and be sure that you meet the need of your country when it comes to disposal. If that is hello, are we there? Hello.
Yes, sir, we are,
Okay.
yes, we are with
So
you, sir.
yeah. So
Hello, we are there.
okay. Thank you very much. That actually
We are
brings
here at listening.
that actually brings us to the end of chapter 3, and then I'll have to move to chapter 4. Before I move to chapter 4, I need to throw it open any question, and so that we can any question. Okay, so we can move on. In the absence of no question, we can move on to chapter.
Hello, sir. I have a question.
Okay. What's the
My
question?
question is for you to throw more light on that raid.
Okay, the rate.
Yes, sir.
Okay. Um, the rate system. What we're saying is that the rate works um, with some condition. And when we're looking at rate, we're looking at how information is being preserved. Before now, if you look at the way you use your system, we said if you have your computer system you're using, and for one or two reasons you have power surge on the hard drive, you lost your hard drive to surge, that is the end, you know. And so it calls for some level of protection. So what we said here is that we said the best way out of this is to see that what you do is you try as much as possible to use a RAID system. And what is the RAID looking at? It's looking at stripping, it's looking at mirroring, it's looking at parity, it's looking at non-parity, as the case may be. Now, these are more or less factors for actually deploying a RAID system. For systems that don't even have these challenges that they go down without some kind of backup. So what we're saying here is that if I must do stripping, the question is that what is stripping and what is a RAID system? For the radio, we're saying what the RAID is redundant array of independent disks. It means technology. That means we have disks connected inside the server. If you have seen a server before, or you have one around in your office environment, you agree with me that servers have arrays of drives, and these drives are actually inserted in the different compartments, and they have links to each other, but it all depends on the configuration. And some of them, if you don't go into the RAID system, you can't be able to configure them. I remember some time ago, I was invited to, I think there's a company, they had issue with their hard drive in the server, and the young man bought, seems to be an IT guy though. When it comes to stuff like this, you need to actually go through this learning process. Some of us we learn on the job. When you learn on the job, it's a very big task because you keep going back and forth. You go back from because there are certain things you don't know. You need to go out. Either you have to use your money, to solve that problem. And so I was invited, and when I got there, I realized that for the fact that they removed the old hard drive that were there and they bought new drive and then plugged into the drive and the server, and the server has a RAID system, they couldn't install new operating system. They couldn't do anything. It's because the RAID system ought to be configured. So even when they tried to format the system, it was saying no hard drive found, nothing found. But meanwhile, this is a new hard drive, and the knowledge of the RAID system comes into play where you now need to get into the RAID, enable those functions, enable them to be able to see those drives before it begins to recognize them. And how do you want it to work? For your information, all servers comes with their own RAID or computer systems. They come based on uh, default RAID setup. In other words, you're not the one that must say, "Oh, you must behave as RAID 5. You must behave as RAID 0. You must behave as RAID 1." So the question is that what is a RAID? RAID has to do with redundant of array. It means that redundancy. What is redundancy? It means backup. It means if this fails, the other one begins to serve. So the primary drive fails, the secondary drive serve. That's what the RAID technology is all about. So how does this work? We have the one that work. We have a RAID system that operates in such a way that as A is as you're saving information into the primary drive, instantaneously is saving into B. The is mirroring the information in A into B. So you have it running concurrently. Then you have the one has that is time based. In other words, after every 5 seconds or 30 seconds, it will now save in B. So you can imagine if there's a power outage for any reason or there's a failure in power supply, the question now is that it might be that the information in A is not exactly as the information in B. So when you're buying any server, You have to be very, very specific and very, very objective in terms of what you're looking for. So we now want to say, okay, if rate gives us the ability to be able to enjoy what redundancy has to offer, and what is that? We said it has to help to what availability. It makes the data to be available in real time all the time. It is reliable. It has the capacity in terms of storage, redundancy, and all of that. And of course, with a modern day operating system, you can actually carry out a cluster. In other words, you can actually cluster those drives such that if I have probably 1 terabyte in all the drives, and I can put them together and have 10 terabytes of storage capacity. It also gives you that flexibility. And so we said, okay, if we have the opportunity to enjoy availability, reliability, capacity, redundancy when we implement RAID, then what are the metrics? What are the factors that enables us to actually say yes, the data will be available, the data will be reliable, the data will be it has a capacity, it has redundancy. We said one is stripping. You will ask yourself this question: what is stripping? Stripping enables data to be or distributed across multiple drives with a significant performance increase. Are you following? However, the failure of a single drive means that all data is lost. I take that again. Stripping. What is stripping? Stripping means that this data is distributed across multiple drives. I get what I'm saying? But a failure of a single drive means that all the data is lost. That means if drive A fails, every other thing is lost. But it's saying that stripping means that as I'm saving in A, I'm saving in B, I'm saving in C, I'm saving in D. But if any single drive fails, automatically we have lost all. So is stripping that very important? Yes, it is. Because it's a process. It's a process of helping you to split your information across all drives. But the point is that it has its own disadvantage that if one fails, automatically you've lost all data. Now, what is mirroring? Mirroring is you store duplicate data on one or more other drives and provide redundancy so that the failure of a drive does not cause the loss of data. So if I have mirroring, it means that information in A is kept in B, or if it's also mirroring in C, it's also in C. When A fails, B automatically becomes A. So mirroring is quite important here, like stripping too. But in this case, I think advantage of mirroring is far, far outweigh that of stripping. Then parity means it provides basic error checking and fault tolerance by storing checksums separately from data and enables the reconstruction of lost data without sacrificing speed and capacity. Parity is like error checking and correction. Your bits of zeros and one on this A to Z forms, it helps when you have your bits of zeros and one of them actually helps you to do the checksum. In other words, to help you check to see if there are issues. So in this case, we're saying if I have parity, it means I have checksum to enable. So if I have a particular RAID system that enables the carry out the combination of stripping, mirroring, and parity, oh, thumbs up, because I am sure that information is dropping across all drives. Mirroring, it means that I have the information mirrored in the other drives in case of failure. Parity, it means that I have a process in place that helps me check for errors and correct them as I go with activities. And then double parity provides fault tolerance for up to two failed drive. In other words, it gives you the ability to tolerate faults. In other words, even when you have up to two drive, it still keeps going you know. So the question now is that we now said if these are the factors or the metrics that justify a rate system, then what are the different types of rate levels? We say we have rate 0, we have rate 1, rate 5, we have rate 6, and rate 10. And then we say the minimum number of drives that you can have in rate 0 is 2 drives. For 1, we say 2 drives. For 5 is 3 drives. For 6 is 3 drives. For 10 is 4 drives. So you can say here that read 10 has 4 drives. Minimum, please, for your information, minimum is 4. So that means you're buying it by default, it comes with 4 drives for it to function. But for the others, They can work with 2 and 3 at minimum level. Now, RAID 0. So if I buy a server that is RAID 0, what do I choose to enjoy? I'll enjoy stripping, capacity, and that's all I enjoy. Stripping in the sense that information goes into the drives, the two if it which is minimum of 2 drives. Let's assume after buying a server or a computer systems that operate with zero and have the ability to put 2 drives, what am I going to enjoy is that information that is in one, end up in two. In other words, as kind of a process for me. But remember, we say for stripping, if I lost one, if one of the drives goes bad for any reason, I've lost my data. Now, the question now is that if I implement that stripping process, because it comes to the server, is there any benefit? That's the reason I benefit from. So we say for RAID 1, it has mirroring. Mirroring in the sense that I will always want to say, okay, if it's just mirroring, okay, that means I have the same content of information in 1, in 2, and like that. So if A fails, B automatically serves. And what happens? The advantage is that performance and what reliability is reliable because it gives you room for backup. You know, and the disadvantage is that capacity is half of total drive size. That's the capacity. Capacity is half or the total what drive size because you have it split, saving the same information, within the system itself. So it's like duplicating the same resources. Then if it's RAID 5, we say for RAID 5, it does stripping with parity. So it has parity in place. And what is parity? We say parity helps you to, it has a checksum to check for error and help you correct the error. Now, in the case of maybe you have a data that is corrupt for any reason, to help you check, do the correction to ensure the data is actually okay. So if you have that process in place and it's doing stripping, and that is what RAID 5 RAID system is all about. If I have a server configured for RAID 5 or works with the ability of RAID 5, some of them will work for, they'll tell you RAID 1 and 5. It has the ability to work as 1 and 5. Some they'll tell you it has the ability to work with 5 or 6, or 5 and 6. So if I have a RAID server that is of 6, he said it does stripping with double parity. Remember what we said the double parity is? And then if I have 10, 10 says it does mirroring and stripping. Now, if I have a server that has a combination of RAID 5 and RAID 10, for instance, it means that I'm going to enjoy mirroring, stripping, and then I'm going to enjoy parity. So what I'm saying in essence is that if you look at it critically, the combination of one or two RAIDs give you better performance. So if you want to make a procurement, you just ask the person, that server we want to procure, what is the RAID ability? What kind of RAID system is in that? Because it comes from the manufacturer. And if you're able to get that, then you now know what the benefits will be. And that's why when you're studying your curriculum, please, there are more information you also need to uh, get across, read in the course of study. And so that rate levels that are higher combine low rate levels. The higher the rate levels, they still have some ability to play with the lower level rate system. So if you have combination of both, you end up taking advantages of what each of them choose to serve. So these are the features associated to RAIDs in terms of redundancy. And what they provide is that give you availability, reliability. When we IT guys goes out there to speak some of this grammar, we tell the people, oh, when we deploy our resources to you, it's reliable, it has a bit. When you speak all these grammars, you're speaking it on the ground because you know the combinations of all the services that you have based on the equipment you're procuring. And this is very, very important because if I buy a system that have no rate system or probably had rate zero, which is stripping, and things fail, they will call you one day and say, you supplied a server. This server, after this thing, we had this issue and we lost everything. It will be embarrassing. But if you know you have this backup also set up, you can actually configure in such a way when they say, "Oh, it has crashed," you can calm down with confidence and be sure that the backup drive is there to give you the same information. So these are some of the things actually I would love us to actually learn from the rate system. I hope I answer your question correctly. Hello, are we
Yes, thank you, sir.
there? Oh, okay. Okay.
I still want to ask that I'm sorry to ask this. I think it's computer system that is configured to be used as a server, or is there any other device that is used as a server? Because I in my place of work, they will tell me this is a server, it's configured, it's called high five, and it's configured to serve at this popular purpose, then it serve every other system. But as you're telling me this rate now, it's trying to throw more light to me that okay, so it's computer system that is actually configured to be used as a server.
Okay.
Hello, sir.
Fumi Lola,
Sir.
I need to say this. I have been to different places. I've seen people use personal computer like your laptop at home as servers. Um, the thing is that the question is that what do you want it to do for you? If I host
Okay.
an application on my system and you guys are going to connect to it, at that point in time, my system acts as a server, because your own system now depend on my own system to be able to carry out that task. What is a server? A server is that a system that responds to request. Your own systems initiate request. So the client systems will be initiating request while the server responds to to the request. So if an application is domiciled in any computer system and every other person is tapping from it, that system automatically becomes a server. But we are looking at beyond um, entry level kind of way of administering servers to an enterprise
Okay.
level. When we say enterprise level, we're saying that imagine that your company now grows and then you now have branches in all over Nigeria, in Africa, and then people now want to connect from all over the world. Are they going to connect to your laptop? Are they going to connect to that small PC that you bought with maybe 2 gig RAM, 4 gig RAM, and all of that? If they connect to it, there's going to be a problem because it will crash. You can imagine some of the client systems might even have better RAM, better processor than that thing you call the server. So we actually misplaced this name for server. Especially those who like folks who are actually coming into IT, newly get confused with this language of server, computer server,
Yes,
PC
sir.
server, and all of that. For your information, um, if they bring in a small laptop and call it server, what I want you to have at the back of your mind that inside that small laptop, there's an application that people will connect to. That is why it is called a server. But then that particular system, that laptop, might not actually have a RAID. Even though it has a RAID, it might be operating with a low end RAID system that might not actually give you a lot of benefit. It might not have that capacity. It might not be that too reliable. It might because to act as a full server in quote. But as your organization grows, you now require that realize that that same small system that you're using, they will have to throw it away or get another one that will be robust. So you will now see a blade server, a big kind of flat device. And then you'll be asking people, what is this one again? They'll say, oh, this one, it looks like a switch. You say, no, it's not a switch, it's a server. Now, when you open it, you now realize that it has memory up to 64 gig RAM. It's a quad core processor. You could see everything, all the components you see on your normal laptop, that same system has it. But this time around in high specification. You will now also see that your laptop, which also used probably as a server in your office or probably in some of the places you visit. In this case, that server now have partitions where they put so much drivers and hard drives in it. But the one you use in your office probably is just one drive. So what we're saying is that there's a scale up in terms of the requirement. And we are when we're teaching the course like it, or when you be teaching your student, you're actually letting them understand that even though a small laptop is used as a server to administer to one or two few systems, but then there are actually computer systems that are built as the main servers. They are more robust. They have high end processors. They have their RAM level is high and all of that. You even have servers that have up to 128 gig. Sorry, yeah, gig RAM. You have 64 and the rest of them. But if you come to laptops, I rarely see that. Even laptop, of course, you could see that. But what we're saying is that it won't scale up as much as this one will because these robust servers we're talking about, most of them they have the components in there have the ability to withstand high surge and all of that. All those things are actually designed in them. I remember buying a power pack for a server a long time ago for as much as 300,000 naira. Just a power pack for a server. But you and I agree, you agree with me that most of the laptops you see around, there's no laptop power pack or anything that can cost even less than maybe 20,000 naira. But I bought one for just one server. We have servers that go as far as maybe 5 million Nigerian naira. We have some for even 6 million. We have some for, so it all depends on what kind of applications you want to deploy and who are the, what number of users are you looking at. Let's say assume in a university environment where students write exams on CBT, and then you have up to close to, let's say you have like 1,000 students that will sit in a hall to write an exam at a go. You won't go and use one small laptop and put there and say everybody should connect. And probably the laptop has 2 gig RAM, it's maybe of a 1.6 or 1.8 gigahertz processor. And then all the systems that are connected around it, might even, some of you might even have 4 gig RAM. The problem you run into is that after a while, the system will be hanging, the server will be hanging. You say, oh, please, we have congestion. I'm coming, let me restart the server. You go and restart the system. People will connect. After a while, again, it will hang. The reason is because that system cannot meet the task, the request that everybody is making, because everybody is initiating requests to that particular system, and the system need to respond to that request at the same time. You can imagine 1,000 students sending in a request at the same time, saying question two. So imagine all systems are saying question. We are requiring we are requesting for question two, and the server need to respond to feed them question two at the same time, possibly. If that is going to happen concurrently, what happens if the server does not have the high capacity in terms of memory, in terms of storage, in terms of speed? The question is that the server will just hang. It will hang because it cannot meet that requirement. That's the reason why we said as activities grows, as the demand grows, you need robust servers because those ones were able to meet up the task. And remember, if you put subject this thing for a long period, there's some, like we talk about web hosting. This server needs to be online 24/7 for the next 50 years, for the next 70 years. You don't want to hear that today we cannot access our website. Our website is down. It is not possible. They said is the customer will make sure you provide. So if you go there and see that server, it's not going to be these small computer systems you and I are looking at here. So just have at the back of your mind that it depends on the application that is installed and the number of systems that are connected to it. Is that okay? So for the RAID system, you have it more functioning in these big servers, in servers that grows, from the different levels we're talking about here. But for single personal computers like this, even though they have RAID system, but the role they play actually are quite very low in the sense that they won't be doing mirroring for you because it depends on the kind of laptop, of course. For most of the laptops that most of us have around, if you check it, it's just one hard drive. It does not have compartment for more drives. So you cannot go and force it and say, no, I need to put another drive somewhere. There's no space for that. Telling you that the RAID system, it does not give you that ability to function as RAID, to scale up like that. So even though you could have it in laptops, will be specially built laptops, and not all laptops now have the rate system. And even when they do, it might not actually be in this order that we're discussing about here. I hope you're getting what I'm saying. I hope that helps you so that you'll be able
Yes,
to
sir. Yes, sir.
be able to differentiate this. So when they say
Yes, sir.
server, you can even ask, please, can I see the server you're talking about? So when you go there, you say, okay, oh, this is what you're using as server. Okay, fine. It means that you have a small application that fewer persons are connected to. No problem. But as the demand increases and grows over time, the organization will have no option but to look for a robust server that even when you see it coming out of the carton, it will be a very big carton, you know. But it's not different from your normal computer. It has processor, it has RAM, it has everything. You connect it to a monitor, you install all you need to install there. And that is why we have network operating systems. The operating system you run on your single laptop is just your normal operating system. But when you want to run operating system in servers, you run network operating systems because it's going to be on the network and we have to actually have to scale up. And when we say scaling means that it gives you room to be able to connect as many systems as possible without any issues. So you can even go to bed and sleep and be sure that even 2,000 students are writing the exam at the same time, no problem. And that is how this actually functions. So if I answer your question correctly, then we can move on. Okay,
Thank you, sir.
thank you too. So we'll go straight to
Please, I
uh,
have a question before we move on.
Okay, go ahead, please. Go ahead.
Okay. Does setting of rate have anything to do with master slave setting?
If setting of rate has to do with,
Setting of maybe master and slave queen for the drive.
if you're going to do master slave,
Yes, most of these IDE drives, those days they used to use setting of master slave for the drives.
when we talk about slave and master, those were the days we used to use sparta drives, cables to connect.
Cables.
Yes, the
Okay.
ID or the ID cable we're talking about. Then the ID cable comes with a dual kind of belt. You connect one to one drive, you connect the other one, and then you have a single unit to the motherboard. Am I correct? And then
Yes.
there's a black stuff you remove from one, isn't it?
Yes.
When you remove that black stuff, more or less from that pin, that one becomes slave. The one that has it is the primary drive. Am I correct? And then you now,
Yes, sir. Yes, sir.
so one adds like a backup to the other one. What that is a difference. It actually it's from there the advancement of RAID system actually came in, because that then what we used to do then was you could slave one so that you can back up your information into that the one that is being slaved, and sometimes you can even move your operating system into the slaved drive. That was then. That is not actually the RAID system we're talking about here. RAID system we're
Okay.
talking about having a, a computer system, a server, a computer server, or whichever computer it is, that has a RAID. Usually, in most of these computers or servers, when you open them, some of them they have a card that you that is connected to your PCI slot. It comes on its own,
Yes.
and then it has connectors from it to the main motherboard, and that is where the RAID activity actually happens. And the beauty about it is that when you go to your setup file, like when you go to the setup, in other words, the BIOS, when you
Yes.
yes, when you get into the BIOS, you will now see the RAID itself. You see, it will even show you the different
Okay.
ports. It will even tell you this port is for this port for that. Then when you enable, you know the particular drive you're enabling for which particular port. I hope you get what I'm saying.
Okay. Yes, I understood.
So that technology is quite different from the legacy one which you and I somehow are familiar with, which is not even happening these days. Most of the systems these days don't even give room for that. You can have SATA cable doing that for you. So, but then I'm just trying to make you understand that for RAID technology, it comes inbuilt with its own mechanism. There is a mechanism inside the motherboard that is tag RAID. And if it's not there, it is not there. It means it won't give you the ability to function as a RAID. And that's why I was trying to share my experience with you guys, that company, when I got there, I realized that it has a rate. And for information, if you are an IT technician and you haven't worked on a rate before, you find it difficult to begin to work on such systems. You sleep all night trying to format a system, and it's not going to format because you need to enable the rate system. You need to carry out that LISO configuration. It's just a step-by-step configuration that will not even take you more than 3 minutes, and you'll have solved the problem. But if you don't know such exists, you wouldn't know what to do. But you can only enable the functions that are in there, and they come by default from the manufacturer. So you're not the one that will create it. You're not the one that will say, okay, and I need to make this server to behave as a RAID 5. I need to make this server to behave as a RAID 0. You can't do that. It comes pre-installed from the manufacturer. But your job now is to get into it, enable it, and actually make it work that way, the way it's supposed to be. Because it might come by default with just minimum of 2 drives, and you need to buy more drives to make it 6, to make it 8. And when you buy them, you now need to configure them to choose which one will be the primary drives and which one will be the secondary drive. So you're the one now to decide. And how do you decide? By going into the setup, in other words, going into the BIOS and then get into the RAID system and then enable it to serve that function. I hope you get what I'm saying. If you get into the BIOS,
Yes, yes.
you will just see it. It's actually spelled out for you to just enable and then get it working. There are no special tasks for you to carry out. It's just for you to know that this exists and these are the advantages and the benefits that it will give. And once you know that, as an engineer that you are, you begin to apply that knowledge and trying to see that it gives you that function. Worst case scenario, you can Google it. Just Google it and say, okay, how do I configure this server that has a RAID 5 or a RAID 10? And then there are forums that give you a step-by-step guide, and then you get going. That is because you have the knowledge of your RAID system. But if you don't have the knowledge and you don't even know anything like RAID exists, you're going to have issues having such service. I hope this actually helps us.
Yes, yes. I will contact you for more questions, sir. Do let
You
me
don't
grab
have
this
any.
back.
In case you get into that thing, this thing, just call me up. I will just give you all the support. Again, I believe you
Okay,
guys have my
okay,
number, so I can actually give you
okay,
remote support from anywhere. Tell you what to do,
okay.
and that will solve the
Thank
problem.
you.
Okay.
Thank
Um,
you.
so let's get to chapter 4. Uh, Please, you guys need to do a lot of reading, a lot of practice. Like I said, that's why we have the WhatsApp group chat. It's a continuous one. If you have issues, you always can post it there. And everybody is meant to give their support. Nobody knows it all. That's why we need to have that group chat. It's a teamwork we're doing here. So if you have challenges anywhere, you can post it in. Those who have the experience will guide you through. And with that, you learn. There's need for continuous improvement. That's how you get to learn and learn and learn. So we're looking at chapter 4, which has to do with preventive maintenance and troubleshooting. Please, I'm going to send the chapter 3 since we're done with it, and then I'll send chapter 4, two of them today to you, the PowerPoint, and see that that actually helps out. Preventive maintenance and troubleshooting. In engineering, we usually talk about maintenance. Maintenance is a very powerful culture in every organization. One of the things that have killed the African settings when it comes to technology is that we have poor maintenance. We are good at procurement, but we're not good at maintaining. And if you ask me, I'll tell you, I visited South Africa many years ago. And then one of the universities, I think Nelson Mandela University, you could see these old desktop monitors still working, and when I saw some of them that were set up with the operating system, they were not actually turned off. The operating system was still there. You come back the next day morning, they are still there. And I was just wondering, I said, here in Nigeria, it's not like our own best practices here like that. Because we still have that shortfall where our maintenance culture is still poor. That's the reason why we easily could phase out the equipment to get new ones. So there's a lot of wastage going on even at the government level and all of that. So maintenance is key, even to private organizations and all of that. So you need to see how to increase your maintenance culture. I remember working in an organization many years ago. Within 3 months or 4 months, I got employed. I was given an award, and one of the ways I actually got that award was it was so easy. When I came, I saw over about 400 motherboards tagged in the store. They tagged them bad because for you to make requests for new motherboard then that was far back. That should be in the that should be around mid 2000. And then for you to, and then computer systems were quite expensive then. For you to actually make a request for new motherboard, you need to bring the old one. So I got into the store and I saw all these motherboards, about 400 of them, and I was like, "You mean all these are bad, tagged bad?" And that was where I actually started my career fully in IT. And I took that stand that I was going to pick up all those motherboards and look at them, check them out to see actually what was wrong with them, probably see the one I can fix, the one I cannot be able to fix, and all of that. And it will shock you. I got over 250 of these motherboards recovered from that junkyard. But then the question you ask me now is that imagine putting around 250 back motherboards into the system. As at then, you can imagine what you'll have saved the company. And so preventive maintenance is key. And I will tell you that 50% of those systems that were tagged bad were actually dust problem. Dust has a way of making the memory go dump, making the motherboard go to the point that it won't be able to work. It will short circuit all the bus wires, all the connections there. Might not be able to help transmit power signals, data signals, and the control signals as we learned previously. All those things might not actually work in full force because it's short circuited. When we say short circuited, we're saying it's like you just saying, okay, if this is a pathway, to move items, somebody just go and block it halfway. When you block it, people can't pass. That's exactly what happens with dust. Dust actually can settle on the motherboard, actually form some kind of stoppage that power cannot flow on the motherboard. And if power cannot flow from one component to the other on the motherboard system, the computer system, the motherboard the system is as well as a dead system. Then picking those mother computers and just blowing air or blowing breeze around them like that, bring them back to life. So you can imagine that also. So we need to have this maintenance culture. But if you don't go through a learning process like this, oftentimes you wouldn't know. Even some of us too, even our houses, we end up not be able to maintain the systems we have, and they go bad. So I think this particular chapter is crucial. It will help you locally and also help your organization if you apply them. So in maintenance, we have what we call the predictive maintenance, we have what we call the preventive maintenance, and we have what we call the corrective maintenance. But in this Cisco curriculum for chapter 4, I think emphasis is placed on preventive maintenance. So I'm going to leave all of that and talk about the preventive maintenance. And possibly as we discuss further, I will talk about the corrective maintenance. So here we're going to see our objectives. Explain why preventive maintenance must be performed on personal computers. Describe PC preventive maintenance. uh, troubleshooting problems with PC and peripheral devices, describe each step of troubleshooting process, identify common problems and solutions for PC, troubleshoot computer components and peripheral using six-step troubleshooting processes. So, benefit to preventive maintenance. Preventive maintenance plans are developed based on at least two factors: computer location or environment. Remember, you can see here dusty environments such as construction sites requires more attention than an office environment, of course. So if you're doing things around that area, I've just explained to us what dust can do. Computer use high traffic networks such as school network might require additional scanning and removal of malicious software and unwanted files. So the maintenance here can be software based and it also can be hardware based. So preventive maintenance dust. Use a cloth or a cluster to clean the outside of the computer case. So you need to clean the computer case to remove dust. You need a blower to blow out dust from inside the computer and all of that. Use hot computer components are more likely to break down. Remove dust from inside of the computer using a combination of compressed air, a low airflow ESD vacuum cleaner, and a small uh, lint-free cloth. I would advise you to use clothes also often like that, but it's good you use the blower to help you blow it off. Preventive maintenance internal component, CPU, heatsink, and fan assembly, RAM modules, storage devices, and data card. So these are like checklists of components to inspect for dust and damage. If sometimes dust makes your RAM to be beeping, you will hear that beep sound, ping, ping. That beep sound is giving you a warning. Once you hear that beep sound, once you go close and you just bring out the RAM and you blow out breeze into, or maybe you blow air into that port and you put it back, it comes on. These are just basic approach to maintaining computer systems. So these are checklists for the different units you need to look out for possible dust issues. So preventive maintenance an optimal operating environment for a computer is clean, free of potential contaminant, and within the temperature and humidity range specified by the manufacturer. So preventive maintenance in terms of software, verify that installed software is current, Follow the policy of the organization when installing security updates, operating systems, and program updates. Create a software maintenance schedule to what? Review and install appropriate security software and driver updates. Update the virus definition files and scan for viruses and spyware. Remove unwanted or unseen programs. Scan hard drives for errors and defragment hard drives. So you see, this is for software. Basically, here you need to ensure that what um, security updates are being done. For instance, your antivirus, you need to make sure the signature is correct. You need at every point in time, if your CMOS battery is bad and it keeps taking you back, you need to change it so that the signature will be up to date. For your information, even though you have an up to date antivirus licensed and your CMOS battery is bad, it's as well as having a bad antivirus, or it's as well as not having an antivirus. And then also and not having your system working well, because the signature of the antivirus will always not be up to date, because it will always be going back to an old date. So you review the installed security processes, probably even patches. Make sure you do update the virus definition, remove unwanted, unused programs. There are some programs that are malicious to your system. You need to some of us, or some folks, install anything, in the course of trying to work on something. Install this, install that, install this. So, when you keep installing so many things, all you're doing is that you're causing harm to your operating system, your software, which won't be good. So what we're saying here is that try to remove every unwanted programs to make your system free of attack. Scan hard drives for errors and defragments. So once in a while, you need to scan and do some repairs on your hard drives to ensure that your operating system works correctly. So troubleshooting process. So what do we call troubleshooting? Troubleshooting requires an organized and logical approach to problems with computers and other components. Troubleshooting is a skill refined over time. Please, I want you to underline the word refined over time. So if you're just an entry level IT professional or IT um, person coming into this class, uh, don't bother, don't get yourself worried. Your troubleshooting skills will grow over time. And for some of us that actually been in the field for many years, it comes with your ability to work on different systems and all of that. And so if you have that, you need to be in that environment for you to be able to grow that knowledge. So before you begin troubleshooting problems, always follow the necessary precautions to protect data on the computer. It's actually very important when you want to troubleshoot a computer system that you back up your data. Very, very important. I must say this before we go on. So troubleshooting is all about finding fault in the system and fixing the fault. And here there are stage steps, 6 steps that as a professional you must always remember. First, identify the problem. Establish a theory of probable cause. What we say theory is that if I identify a problem, I need to know the theory behind that problem. I need to know what causes that problem. I need to get to the root cause of that problem. And how do I do that? By gathering the knowledge associated to that problem. For instance, if my system comes on, shut down, comes on, shut down, I need to identify the problem. And the problem is that the power is intermittent. The power um, is not stable. So if I identify that, then I need to establish a theory of probable cause. I need to begin to ask myself, what are the devices of this computer that actually require power at every point in time at first, and to be able to give me a better output? One, I say, oh, the power pack unit. Two, what else again? The CPU requires power, being the brain. So I will now want to check my power pack to see that if my power pack is actually carrying power, and then check the output of my power pack with a multimeter, probably to check the volts to be sure that it's actually giving an output of that particular volt. And once that is confirmed, I now want to check to be sure that there's a power going into um, the CPU area. So once I'm able to check this, or check, oh, is my fan actually being powered? Is my fan working well? So all those units that take in power to drive a process immediately, try those common components. You need to check them out first. So you now have to establish that theory. You test the theory to determine the cause. You test the theory by checking them out, by testing to see if they are working. And that is how you test it. Establish a plan of action to resolve the problem. Then you now come up with a plan of action. Oh, I have tested it. Oh, I can see that the voltage that is being delivered by the power pack is not up to 24 volts. Oh, it's like 14 volts. What do I do? I now need to go and get another power pack and put, and all of that, and see that. And remember, the form factor of the power pack was matched with the previous, so that at least you're sure that you're actually getting the right power to drive the motherboard. So once that is done, you'll have established a plan. So the plan we're saying is that you come up with a step-by-step approach on how to resolve it. Then verify full system functionality, and if applicable, implement preventive what measures so it does not happen again. Document findings, actions, and outcomes. Please, this aspect of step 6 is very, very important. If you're working in your organization, have a logbook where you put all these things, you know. So how you solve every problem in the organization, put it in logbook. I remember far back in the company I was working before, we do all many years ago. These are things we do. Even up to date, I still remember something I was talking to a friend and he said, "Oh, those your logbooks are still there." And it's been helpful. You see, it helps the new technician that is coming to read this book and say, "Oh, there were issues like these. This is how the person was able to establish the problem. This is how the person tested it. This is how the person was able to resolve the problem. This is how the person was able to look and to implement measures not for it to happen again. This is how." So we actually were working based on this approach, the troubleshooting process. So I would advise you that if you don't have such in your organization today, try, talk to the management, tell them, please, henceforth, every troubleshooting that must take place in our organization, let us have a logbook and such that whosoever saw any problem, put it in that logbook. So if it's going to happen again, somebody can refer to the book and see how that problem was solved. And that is very important. I remember also I was working on the VSAT some years back, um, and the VSAT had a problem. We're pointing at a particular line of sight based on what was given to us, the frequency given to us by the ISP. And but then we're having this time out at a particular period. There will time out and the signal was not okay. And we did everything possible to resolve this problem. We couldn't. In fact, at the point in time, the ISP told us we had to change the position of the dish, that they would give us a new satellite. And I sat down one day and I said, no, there must be a solution to this. And then what did I do? And I looked, and then I realized that the dish was one pointing close to a mast, an MTM mast. So it's so possible that there was an interference from the mast to the dish because of the frequency of operation. And so what I did was I felt that for me to boost the signal of any network, or normally for signals, if you want to boost signals, you can actually put in power. So if you increase power adds strength to your signal. It also introduce noise. So you must be careful how you put in power. So what I did was, I remember vividly then, I increased the power into the LMB and I tried to increase it within a minimal range. And then because of the increase in power, the signal becomes very strong. Even though some little noise was introduced into it, but the noise was minimal such that you can't actually notice that. And that solved the problem. So there and then the ISP guy told me, how did you solve this problem? Because they were really waiting for me to call some civil guys to break off the whole civil work there and bring out the dish and go back again and remount it somewhere else. But then when I told them how it was solved, immediately it was documented. They were sure to get the step-by-step guide. So these are how these white folks work. They get this information, they document it. Before you know, they even write a book out of it. And they go back to the lab, rework on the same thing and fix that problem for the future. So we also need to begin to come up with such kind of culture. Culture where when things are solved, put them down, it will help a lot, you know. So I've told us how to identify the theory. And so if you go through the various steps, it gives you a guide for each of them, what you need to do for the 6 steps. So for documentation purposes. Now, PC common problems and solution. Computer problems can be attributed to hardware, software, network, or some combinations of the three. There are some common hardware problems. Storage. Storage devices problems are often related to loose or incorrect cables, not being connected, incorrect jumpers, and BIOS settings. And so when you have all this, it affects that. So if your cable is not properly connected, you can have such issues. Motherboard and internet components. So ensure that everything in the motherboard is properly connected. Power supply problems also causes another problem, loose connections and inadequate wattage. This is also very, very common. If what drives your system is 220 volts and what is coming in is less than maybe 120, 130, you're going to have issues. Your system will not come on. So you need to also check that out. CPU and memory. So you also need to look at the cause of fault installation, incorrect BIOS settings. You always need to go into your BIOS to be sure that it's well set, inadequate cooling and ventilation, and compatibility issues. These compatibility issues is very crucial. Make sure that at every point in time you're using the main. Don't some of you want to upgrade your system, RAM memory. It might come with a default memory of 4 gig. Some of you say, hey, it must be 12 gig. There must be a requirement, a level threshold for upgrade. So when you're doing upgrade, you do upgrade such that you're sure that it can be able to carry it. Displays. Display problems are often caused by incorrect settings, loose connections, and incorrect or corrupt drivers. This is common those days when if you don't have drivers for VGA, you might not have display and all of that. Unlike today when most of the operating systems come with the plug and play. Once you plug it, you're sure it's going to work. Common problems and solution for storage. So look at this. Computer does not recognize a storage device. The computer does not recognize an optical date. So remember, I gave you guys an assignment before now for the lab. I think when you read through all this, it will help you for some of the findings and some of the functions of those components to give you a strong guide. So I might give you the opportunity to submit this assignment between now and Wednesday, and so that you can do more research. I just have few persons who submitted. Because when I give assignment like this, I just want you to learn. I want you to go out there and search to get more information. You can as well read ahead of me. You can some of you can if you like you can read all the chapters before the next class or if you have the time. Usually a course like this we usually enroll students even 2 3 weeks before the time. So they can read ahead because you're an instructor. As I'm talking to you, I'm talking to an instructor. I'm not talking to a student. I see you as somebody who is going to teach others. So it means that you're ready to learn. You have the capacity to process high level of information, and you're not ready to give up at any point in time. So if you're discouraged with a program like this, then you can imagine your students how how they're going to feel. So it means that you must have that ability to sit down one place and study hard to know it because you're going to instruct and you instruct based on what you know. That's why you need to study hard. So please try as much as possible to read and read and read ahead. Go a long way. The curriculum is such that it will help you. When you read, you can read with understanding. If you have any issues, that's why I'm here. Like I said, always send in your question and I'm ready to discuss them in class or even after we're done with the program. I'm still reachable and I'll still give you all the necessary support. Okay, so common problem solutions for storage. You can see that this is already outlined, a step-by-step guide. The computer does not recognize an optical disc. What do you do? The computer will not eject the optical disc. The computer does not recognize a removable or external drive. These are associated problems for storage drives. Remember, we have different types of storage drives. Of course, across your optical, your hard drive, your external drive, your USB, and all of that. And so we have common problem solution for power supply. So we also have the same for power supply. So I would advise that You just run through the six processes and see how they operate. Applying troubleshooting processes to computer component and peripheral. Personal references tools include troubleshooting guides, manufacturer manuals, quick reference guides, repair journals, in addition to an invoice. A technician keeps a journal of upgrades and repairs. So a technician at every point in time must refer to manufacturer manuals, reference guide. You must also be online using online search engines. These are all tools that you need to be able to help you. Make notes as you go through the troubleshooting and repair processes. Um, Journal include description of the problem, possible solutions that have been tried to correct the problem. You need to look at it. History of repairs. Make a detailed list of problems and repairs, including the date, replacement parts, and customer information. The history allows the technician to determine what work has been performed on a specific computer in the past. It is good when you're working for a customer. This is your system. What has happened to it before? Have you given it out for repairs? What and what? If you have the history of likely problems with that system, it gives you a good guide. And that's why you don't just jump into any system and start fixing. Those things they help you to streamline your tasks. In other words, what you'll be doing on the system. The internet is an excellent source of information about specific hardware problems and possible solutions. Internet search engines, we've said that, news group, manufacturer, uh, frequently asked questions, online computer manuals, online forums and chat, technical websites. You see, so nobody knows it all. In troubleshooting, you use all these different sites, all to see how much knowledge you can gather to a particular problem. So if you feel free, oh, I'm seeing a blue screen, my system comes on, we show a blue screen after a while, it's shut down. It could be attributed to so many things. It's possible that some of the RAM memories are getting bad. It shows that it shows that you installed a previously installed program was not good, compatible with your operating system. So it's showing you that you need to uninstall it. And so the blue screen might just be for safety, might be for protection of the system, might not necessarily to scare you, but rather to tell you that what was installed before wasn't good. So all you just need to do is that you put the system into a safe mode, uninstall whatever you installed previously, or you do a restore, and then you see your system coming back to life. So, and then if you don't have prior knowledge on what to do, you can go online, just type the problem. There are 1001 persons who have solved the problem and have made it available online, and you can learn from there. Please use those tools. The advanced problem and solutions, RAID stop working, RAID cannot be found, the computer exhibits low performance. These are different issues, so you need to check it out. So for the lab, when you're in your lab, use a multimeter and a power supply tester to test. So you use a supply tester to test if there's current in the socket in case when systems are not coming on. And then you use a multimeter to test the voltage. In the multimeter, it is written there. You see volts, you see amperes, you see resistance, all those calibrations. They are there actually to help you read exactly what the output is. So if I take a multimeter, for instance, and I check the voltage and the voltage is less than maybe 170 in case of in Africa or part of Africa where we use 220 volts, automatically what happens? You now need to say, oh, the power is not sufficient. You can actually say, oh, let them go and on the generator or get an alternative power source and supply. And that actually is the problem. So the tester is to be sure that there's current in that socket. So these are tools. So you expect to do this, to perform this before your students, let them see. So that means that you need to buy a multimeter and you need to have a tester. So actually that brings me to the end of this preventive maintenance. But also I need to say this in terms of preventive maintenance, that when you're preventing, you're trying to avoid, you're trying to uh, see how you can stop the system from crashing, you know. So what you're trying to do is to put in some guides. And that's why the 6 steps are quite important to be able to carry out proper preventive maintenance. In addition to this, you need to get like power surge. You need to get uninterrupted UPS, uninterrupted power supply. You need to have a stabilizer to be able to stabilize the voltage. You need to have you need to have you need to have a good earthing system, like I said last time. All these are measures to ensure that you protect your system. Like that surge breaker is very, very important, and you need to be sure that your surge breaker is working because some of them fail after a period of time. So you need to know when they fail and you need to replace them so that you don't end up having issues. So once you're able to do all of this, you're sure that you're actually helping to improve on the performance of system in your organization, as the case may be. So I'm going to stop here and give us room to ask questions, and then we can discuss other things and then move on with the other chapters. And like I said, I'm going to forward you guys to chapter 3 and 4 so that you can, if that will help you to understand the material better, I'll be fine. I'll do that immediately after now. So, gentlemen and ladies, any question, please? I hope you find the class interesting. Hello, are we there?
Yes, we're here. Thank you.
With
The class was
Okay,
really, really interesting. I enjoyed today's class.
okay. So, any questions so far? Some of us will just connect, and one good thing about virtual this is that some of you will just connect and walk away from the computer. And come back when you want to come back. Hello, are we there?
Yes, we are with you, sir.
Please, any question,
Yeah.
any question, or I should begin to ask questions and call names. If I call your name, you answer my question. Chidi, Chidi, you ask me a lot of questions, so I'm going to ask you a question. Chidi, are you there? Chidi, 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 Okoro, are you there?
Yes, sir.
Good, Chidi. I'm going to. If you don't ask me question, I'm going to ask you questions. So I'll give you guys the next 3 minutes to ask me questions. If you don't ask me, and I'll use the remaining 5 minutes to ask questions. So I'm giving you. If either you bombard me question now, so I will not have the time to ask you questions. Or else I start calling names, or you start signing out. Some people start leaving. Eh? Some people start leaving when I say I'm going to be calling names because you don't need to call your name. Mind you, this is a virtual world. We don't know each other. We don't see each other. So
Well,
uh, feel free.
hello.
Feel free. Yeah, go ahead, please.
This is Olufemi Odunlami.
Okay, Olufemi, go ahead.
So, yeah, though I still have some issues understanding that rate system because I joined late, so so as not to drag the class back, I'll try and make my own little research about it. So
Okay,
that's just what
Olufemi,
I
you
have to say.
joined late. I actually reviewed that again because that was where we stopped last time. And then, but
Okay.
in summary, I tried to see that we don't overflog a particular subtopic to the
Okay.
detriment of the other topics because so that we don't scare the other participants who are trying to come up new. And but then
All right.
for the sake of the course, there are basic knowledge we need to get at the different topics. And even the questions that you also see will also guide you through to let you know that uh, this is a combination of different fields put together to prepare a curriculum like this. It will shock you that this course you're doing has computer engineering, has electrical engineering, has computer science, and what else again? Has physics. So you can say a combination of whole lot of fields coming together as one, because this is what we call applied science. So when you're reading a course like this, the aim of the academy is to drive your knowledge to the practical aspect of it. So drive your knowledge to know the application aspect of it. So when we talked about the risk, the last time, and the CISC. We said one is the reduced, is also instruction set, and the
Yeah.
other one is a
Yeah.
complex instruction set. Now, in summary, what the two entails is that the one that is reduced instruction set is the one that is helping you to make it faster, and the aim is an improvement over the other. The CISC actually is the 8086 kind of processor, and that is where you have that complexity instructions, and the logic circuit that are involved actually are quite high, a lot, and then a lot of instructions that must be passed for it to work in. So the architecture of the CISC seems to be complex. But as technology improves, it's clear that the risk came in. The risk came in to reduce the instructions to do more. In other words, to do more tasks. So we're saying that it is not about the complexity, but it's about the ability. So the risk has more ability than the CISC. And I did told the class when we started earlier, I said the risk is applied in telecommunications, in for video conferencing, because of the ability to be able to carry out more tasks. In other words, the efficiency is quite high in the case of the risk. So it is actually used in all these high-end servers and high-end organizations because of the processing ability. In other words, the risk has high transistor budget as compared to the CISC. So where do we now use the CISC? These are just instructions. And what are instructions? We're talking about telling you what the processor should do. And what is instructions going to do? To fetch information, decode the information, and execute the information. So the two of them are actually fetching information, they are decoding information, and they're executing information. But the point is that one is used in a high-end environment based on the task, and it has the ability to be able to give such high performance and high output, which we said is a risk, which is used in telecommunications, in for high graphics and purposes and all of that. And for the CISC is not used for high end processes like that. The CISC is used for low end. In other words, like when you have your CCTV cameras, so you can imagine those small appliances that runs on microprocessor, but they just require some little processing ability, and that's all. CCTV camera, for instance, has processor inside, but it's quite small. So um, what we're saying is that it does not require high-end processor to do so many things, or to subject it into high tax. So that is just the difference between the two. So the difference actually comes in the ability, in the performance. So you can say the risk is actually like the modern day processor because of its ability to do more. But the point is that the two of them are being used. And I said one contrasting thing there is that it's still based on the transistor budget. What makes a processor be able to perform very high, in other words, in terms of efficiency, is the number of transistor budget inside the processor, which the risk already have. So, and which the six also have its own. So the point here is that we need to know when the two is being applied. The two of them are being used in the industry, but they are used based on requirement. They are used. I can't go and carry the six and be using for telecommunication equipment, be using for high graph. It's not going to give me that result. Reason is because the complexity in the instructions makes it not to fetch information at a very high speed, makes it not to decode at a very high speed, and makes it not to give me the output at a very high speed. So if I use it in such environment, I'm going to have issues because it will slow down a lot of activities and a lot of processes will not work well. So I hope that helps you so that when you're reading the material, it also gives you a better guide.
All right. All right. Thank you very much.
I hope this information is useful.
Yeah.
Hello?
Very, very useful.
Okay, thank you very much.
Hello?
Yeah, hello.
Hello?
Yeah, I
Yes.
can hear you.
I wanted to find out what is the likely cause of USB ports being disabled on a PC and the solution to.
Why is it disabled? And the solution to that?
Yes, yes.
Yeah, in most organizations, they wouldn't want people to come in and plug in USB drives so that you don't have virus get into the system. So most organizations have it as a matter of their policy as part of their policy to disable the USB port so that people don't put things.
No, Twitter. It's a situation where you have a PC working with all the ports working. Just the other day, we found that all the ports are disabled and you can't plug in anything.
Disabled on its own. Somebody has to disable it. Am I correct?
Hello?
Somebody disabled it.
Hello?
Yes, I can hear you. I said somebody disabled.
Yes, yes, we just found them disabled. Not maybe really someone disabling them, but just found them disabled.
I can assure you that if those PCs were the USB port were disabled, one of you or one of your colleagues actually disabled them. Nothing else can just
Maybe by
disable. Of course, you say if all the USB ports are disabled for any reason, it means that somebody actually disabled them for one or two reasons.
Okay.
Yeah.
But is there a solution to that?
Yes, of course. You can go into the device manager and look at the USB port there and then enable it back. It's possible. All you just need to do is just go to the device manager and locate where the USB ports are and then put them back. Just enable them back. You can disable them and you can enable them. So you can just, all you need to do is that go back to the system, go to the device manager and then locate the USB and then enable it.
Okay. I hear that, but the challenge is now how do you connect to get to, because all the ports are disabled.
That's what I'm saying. You just go to device manager. No, the device manager is right there in the system. So when you boot the computer system, you go to your PC, then you locate your device manager, and then you will see the different component inside. Device manager actually displayed all the uh, items you have and let you know whether they are functioning or not. And when you click on each of them, it actually tell you the status, and then you can go as far as disabling it or enabling it.
Meaning you use a PS2 mouse, because the USB ports, all of them are
Okay. From what
disabled.
you're saying since it's already disabled, how do you get in when you cannot?
Yes.
Okay, I understand what you're saying now. Okay,
Yeah.
in this case, if you have a
Yeah.
PS2 mouse, you can do that, but you can actually use the keyboard. Sorry. Okay, if you have a wireless keyboard, you can use a wireless keyboard. Okay, you still need the USB though
Okay.
for the stuff. Okay, no, but I think the PS2 will go a long way. That is one.
Sure.
And then if that person actually disable all the USB port, I can give you one advice. You can actually get another USB card.
Okay.
It's handy, and all you do is you plug it on the PCI's slot inside the motherboard. Mhm. Are you following?
Yes, I'm getting you.
Yes.
Yes, I am.
Just get an external USB card, plug it inside your motherboard, and connect your cable to it. Once you connect your cable, your keyboard or mouse to it, you can now have it working, and then go in and then re-enable all of them.
Okay. Okay.
Yeah. So
All
with that,
right.
you can
Thank
actually
you
get
very much.
that. You can get that from the market. It's not too expensive. There are even some that I don't know how much it costs in your area, but I think it's quite cheap.
Okay.
Yep.
Okay. Thank you very much.
You're welcome. Which operating system does RAID system support most? You have RAID system. You have the Linux operating system. Virtually all these operating systems support the RAID system.
There are many
Then you
using
can also see this is coming from Jegede.
no, this is Victor.
Okay, it's coming from Victor.
Yes. Yes.
You have a question?
No, it's me who asked the question about the USB ports being disabled.
Yes, and I hope you're okay with the solution given.
Yes, I'll need to try it. I'll need
Yeah,
to try it.
no, it's going to work if you get the USB card and plug in. It will work. It's going to work.
And okay, thank you very much.
And then we also have the one that has a converter. You could even have the one maybe from VGA to USB. You have
Okay.
So you could get converter that you could use. Not necessarily, you can't even plug it in the USB again, but you plug in a different port, and it gives you USB at the other end. So if you get such converter, you can even plug it directly and convert it, even from the HDMI to USB. You can have converter like that. So if I have such converter,
All right.
you could have VGA at one point and have USB at another point. I don't know if you have seen converters like that. They are there are converters in the market from VGA to USB.
Okay.
So when you buy the VGA to USB, you plug that converter to the VGA port, and then on the other side you already have a USB, so that you can connect your mouse or your keyboard, and then you get into the system and then enable everything back. I think the person just did it just to frustrate the other folks.
Okay.
So I don't think some, like in my former organization, because they didn't because of proprietary information, they didn't want anybody taking their knowledge, their works or drawings. It was an archive firm. They also disabled USB. So I don't think it's to frustrate. Sometimes they just don't want people taking out data or information.
Yeah, even if they don't
Research.
have people, but the truth is that that's what I told him. I said it might be for one or two reasons, but then some other person can also do that to frustrate an individual. It's possible. Somebody can do that. So the intention, if it's the organization, I think Mr. Victor ought to be aware. And if he's not aware, then I don't think it's a policy, because if it's a policy in the organization, every staff should know that USB ports are disabled for security reasons. And then, but then, if it is not in the policy, then somebody else will have done it to frustrate the others. And then, but there are solutions. You have converters, you plug them, and they give you what you want. So if the organization does it for security reasons, then they might not really get it correctly, because I can have a converter put in my pocket and plug it in and connect whatever I want to connect and go back. So what happens? At the end of the day, is the person still gets the information, but at least it's not coming handy this time around. The person needs to do some extra work here. Okay.
Yes, true.
Yeah. So we need to know if it's the policy or it's just an individual trying to do that. Sometimes I have seen individuals in the organization trying to protect a particular system, and they just implement that on that system. Maybe they have sensitive information in that system and they wouldn't want anybody to have access to it. And of course they have their reasons for it. Okay, and then they have their own external USB converter in their pocket that they always use to work on that system. Okay, so which operating system does RAID? I've said that it supports all network operating system. um what Okay, there's a question: what is the best approach to fix an inbuilt battery that is not charging even after troubleshooting from device manager? Okay, this question is: what is the approach to fix an inbuilt? That means it comes factory fitted with the system. So what is the approach to undo this? You can actually get an external power backup for that, which is also, I think, is available. But what kind of system are we talking about here? You need to let us know. The ones that has the inbuilt. Is it a computer system you're talking about here, or you're talking about an embedded device that works with some power? We need to know which device you're referring to. This is coming from Habib Bello. Habib, you need to tell us which device has the inbuilt power system. Because some of them that you say inbuilt power system, to shock you that it's not inbuilt. There are still ways to bring them out. Okay. Yeah, somebody is asking me what is the topic for today. I hope this person is with us. Zainab, you're asking me what is the topic for today. Hmm? Zainab,
Hello.
if you are with us, you should have access to the curriculum online. And the curriculum online spelled out all the 14 chapters, all the topics. So you need to go into your profile. If you have issues, log into your profile. You still let us know. We can solve the problem. So the topic
Hello.
today we talked about is maintenance. That's chapter 4. Yeah, are we together?
I have a question.
Yeah, the rest of us are quiet.
Hello.
Yeah, go ahead, please. Banda, go ahead.
I just I just wanted to seek for clarification. I think in the last class you did indicate that you're going to demonstrate on how to install the virtual box and also Linux and the packet tracer. Is it going to be done today, or when are you going to do that?
Okay, that's a very good one. I just realized that for me to do that, there are topics that has um, that we needed to cover. Showing you how the
Okay.
virtual box system works. I'm going to do that, but then you need to learn. I can see chapter 5 is network, so you need to learn network.
Okay.
You need to know some basic components of network. So I wouldn't want to be in a haste to demonstrate a practical that we haven't covered the topic. So it would be best that we'll have done
Okay.
Linux, done network, advanced networking, and all of that. Cover all those chapters so that when we're discussing it, we'll be on the same, the same level. I don't need to be taking time to explain something.
Okay. I think it's clear,
So
yeah?
let's look forward to that, Brandon.
All right. Okay.
Yeah,
Thanks.
somebody said Core i3 has 4 cores. Who told you Core i3 has 4 cores? Core i3 has, yeah, you have Core i3 with 2 cores. It's not 4 cores. Hmm? Say Core i3 has three. Say it has 3 cores, but one of the cores is disabled. If one of the cores is disabled, then it's 2 cores. So, but I gave an assignment, so you can do the assignment. Let's get your feedback. So let's know what you're finding.
Sir,
This is coming from Abdul Kadir. Abdul Kadir is giving us an assignment, so you should do that assignment. Okay,
please, I
Hello.
put a question on it. I don't I have attend to you.
my assignment. You said who is speaking, please? Abdul Kadir. You
Uh,
said
Bello Abid from Mina,
Abdul Kadir
Nigeria.
from Mina.
No, I'm Abid. Bello Salah Abid from Mina.
Okay, go ahead.
Please, I posted a question on the group chat. I don't know if I have attend to you.
Where?
On the group chat,
What was your question?
I'm actually trying to troubleshoot a laptop whose in this battery is not charging. When you charge a particular level, maybe 70%, it will stop charging. And I've tried to actually troubleshoot. It's still not working, and it's an Indian battery that I cannot remove the battery. I was not asking that, is there any other way that one can actually fix such a laptop?
Okay, you charge it up to 70% and it doesn't charge beyond 70%.
Yes, sir.
Hello?
It doesn't charge me on 70%.
What you said is that it will charge up to 70%, but it does not go beyond 70%.
Yes, sir.
If
It
you
will
can
stop
charge
charging.
it and it gets to 70 and
Yes,
does not go beyond 70%, because that I need to ask this question. Are you using the right power adapter to charge the system? If you think you're using the right, because if you're using the wrong power adapter to charge it, you might have issue. And obviously, I would advise that you check to see. If it's not the default power pack that comes with the system, you need to get the default power pack. Be sure that you're actually sending the right wattage into the system to charge the battery. Certain batteries, for instance, are meant to be charged by 120 watts. If you buy a new adapter, it might be giving 150 watt and might not be able to charge the battery very well. In so doing, you're actually killing the battery. That is one. Two, if the battery lifespan itself is reduced and the battery is failing, so-called failure component rate, then the battery is a matter of showing you a sign that, okay, I'm failing, I need to be replaced. But first, in the troubleshooting process, I want you to be so sure the adapter itself that is charging the battery is good enough by checking the right wattage at the back of the system that comes with it, and then check the adapter to be sure that it's giving you that particular out. These are just basic troubleshooting to be done. And if you have done all of that, now advise that you get a new battery and put check the difference instead. But please be sure that the power adapter is the right one. And be very careful because there are fake ones out there. Okay. So, gentlemen and ladies, we've come to the end of today's class. My
Hello,
assignment.
please,
Yeah,
just this last question, please.
go ahead, please.
About the chapter 2 assessment, I don't know if it will be reactivated so I can take it again. Is it possible?
Yeah, sure. I will. I'll reactivate it for all of
All
us.
right.
Yeah, please.
All right.
You
Thank
can go
you.
ahead and write your 3 and 4 now, please.
Okay. All right.
Be rest assured, as many times you want to write any of the chapters, I will enable it for you. The aim is to have
All
the
right.
knowledge. It's the knowledge you are interested in. But please, you must pass my exam. If you fail, you, you will not be given that profile. Oh. I need to tell you from now. Hmm? You must have there's a requirement for the course. You must meet the requirement. But for all your chapter exams, be rest assured that if you want to write it 6 times, I will re-enable it for you 6 times.
Okay.
Yeah. Okay. So thank you all, and I believe you enjoyed today's class.
Yeah.
Yes,
Thank you,
thank you
sir.
very much, sir.
Mm.
Really enjoyed it. Thank you.
Somebody is still complaining about reattending the chapters. I'm going to re-enable all of them again. So feel free. I know Chidi has written his. Chidi sent a message that he hasn't written. He wanted to write chapter 1 or so. But I believe he would have done that. Chidi, have you done that? Chidi, have you done that?
Yes, sir. Sir, I've written my, sir, of course, I've written my chapter 1 and chapter 2, sir.
So when you send a complaint like that and it's solved, at least there is a need for a feedback to say, oh, thank you, sir, I've done that. Or you just let us know.
Okay, thank you, sir.
Uh-huh.
I'm very much sorry, but I sent it in
Not
my
not you
in
do
the
that
group
on
chat,
your
sir. I
forum.
sent
Let
it
us
in the group
know
chat.
when your problems are solved. Let us know when it's not solved. Because most of it is when it's not solved, you come to the forum here and you just scream. Like Fumi Lola will come and repeat herself here, you know. So when it is solved, the same way you let us know it has been solved. So that instead of you just being
I did
quiet.
I did just that at the group chat, sir. I did just that.
Okay, great. Please do that. Always pass those information
Thank
back
you,
to the
sir.
group chat so that the others who are also having challenges will feel free to send in their problem. Okay, thank you very
Thank you
much.
very much, sir.
Yeah, have a
Thank you,
lovely
sir.
day. Yeah, good
And
night.
you too, sir.
Yeah,
Thank
good night, everyone.
you. Bye.
Thank you, sir.
Yeah, bye. Yeah.
Thank you.